Welcome, and thank you for joining this webinar, Wireless Driving the Automotive Machine to Platform Transformation Executive Summary, prepared by Albert Research Team. Today, we're exploring one of the most profound shifts happening in the automotive world, the transformation of vehicles from mechanical machines into intelligent, software-defined platforms powered by wireless technologies. We'll move step by step to build both a technical and strategic understanding. The big shift, how wireless is enabling the transition. Market drivers, why this transformation is happening now. Wireless technology toolkit, a comparative review of the key technologies. Practical applications, real-world use cases. Manufacturing transformation, challenges and risks, and future outlook. Let's start with what we're calling the big shift. Historically, cars were mechanical beasts. The major change now is this rapid pivot towards the software-defined vehicle, the SDV, and wireless connectivity. It's not just a nice-to-have feature anymore. It's really fundamental plumbing, the infrastructure that makes it all possible. And this isn't just theory. The global market for connected car solutions projected to hit something like $148.6 billion by 2030. That's an 18.2% compound annual growth rate. That kind of growth that really signals a massive strategic shift.
Why this is all happening right now, it's not just one thing, it's more like a perfect storm. You've got regulatory pressure, you've got sky-high consumer expectations, and then just huge industry investment all hitting at once. Safety is always a major driver. The EU pushing for things like child presence detection systems directly pushes car makers to adopt new wireless sensing tech, like specialized radar for inside the cabin.
And on the consumer side, pace, we expect our cars to feel less like, cars and more like our smartphones, always updated, always connected.
That seamless digital experience, things like digital keys using your phone or really good in-car Wi-Fi, they're not really optional extras anymore. They're becoming table stakes, key differentiators. And this leads us to where the money's going, the overall automotive wireless module market. It's growing steadily, about 9.2% CAGR predicted through 2034. But compare that to 5G specifically in automotive and smart transport. That's forecast to explode. I get a combination of 28.32%.
That difference is nearly 3 times faster growth for 5G. All that investment is funneling so aggressively into mission-critical 5G. Doesn't that create a bit of strategic risk? Are manufacturers maybe jumping ahead to L4 autonomy tech before the basics are totally reliable for everyone?
That's a really sharp point. It does highlight a calculated risk. It's based on where they see the future value. That aggressive investment signals a couple things. First, 5G is seen as pretty much the only way to eventually make money from high-level autonomy, fleet services, that kind of thing. And second, manufacturers are willing to pour money into that low-latency infrastructure now. They want to secure their place in this new continuous service model of the SDV. It's definitely a bet on mission-critical intelligence over, say, just general convenience features.
Let's unpack this connectivity tool. That mission-critical focus means using a whole bunch of different wireless technologies, different tools for different jobs. Let's start with the big one, wide area connectivity. Basically, cellular, 4G, and 5G.
Cellular is the backbone for long-range stuff. It enables telematics, remote diagnostics, and those crucial over-the-air OTA software updates. And 5G specifically brings the promise of URLLC, ultra-reliable, low-latency communication. That's absolutely non-negotiable for higher levels of autonomy.
Low latency. 5G's goal is ideally 1 millisecond, right?
That's arguably the single biggest technical mountain to climb for autonomous driving. Achieving 1 millisecond. Possible, maybe, under perfect lab conditions, but consistently staying under, say, the 10 millisecond ceiling needed for safety function. It's not just about the radio signal itself. It's network slicing, dedicated quality of service.
Beyond cellular, we need stuff for closer range, inside and right around the car. That's where you see things like Bluetooth Low Energy, BLE, still handles basic pairing, low power sensors like tire pressure monitors.
UWB is a game changer, absolutely. For getting into your car securely, because it uses this huge slice of bandwidth for very short pulses, it can pinpoint location down to centimeters. That precision is key for secure digital keys, the whole phone as key thing. It knows exactly where the signal is coming from.
And then for just raw data inside the car, streaming movies on multiple screens, maybe cloud gaming, downloading a massive OTA update quickly, that's where Wi-Fi comes in. Wi-Fi 6, 6E, maybe 7 soon.
Precisely. That's your high bandwidth backbone for infotainment, keeping everyone connected and entertained. V2X, vehicle to everything, and cellular V2X, or CV2X, is really taking over as the global standard here. That covers vehicle to vehicle, V2V, vehicle to infrastructure, V2I, even vehicle to pedestrian, V2P. The real magic of CV2X, its non-line of sight capability. Your car can get instant, secure warnings from other cars or roadside units that are completely hidden from view. It complements the onboard sensors, gives the car a much wider awareness.
shifting gears from the tools themselves to the strategy, how are these wireless capabilities actually being used?
Wireless is the delivery mechanism that makes the software-defined vehicle a reality. OTA updates, whether that's SOTA, software updates for infotainment, or FOTA, firmware updates for critical driving systems let manufacturers constantly add features, push security patches, even run remote diagnostics. And that fundamentally shifts things. It's not just selling a car once. It becomes a continuous service, potentially subscription-based, lasting the whole life of the vehicle.
Today, maybe 1 in 4 new cars can do OTA?
Roughly, yes.
But the projections show that jumping to nearly 78% of all new vehicles by 2030, that's a massive acceleration.
And the potential impact of V2X on society is just as huge. Think about safety. Studies estimate that if V2X is widely and effectively implemented, it could help avoid something like 80% of accidents. Just by sharing real-time hazard information, preventing collisions before they happen, that's transformative for road safety.
We're also seeing wireless enable some really fundamental changes in EVs, especially around the battery system.
Wireless battery management systems, WBMS, this is a big one. It's a structural enabler for designing better EVs. Think about all the complex wiring harnesses inside a traditional battery pack. WBMS replaces most of that with reliable wireless links. Well, fewer wires means simpler assembly and more modular design, but the weight saving is significant, maybe 10, even 20 kilograms. And maybe more importantly, it gives designers more freedom. They can pack cells more efficiently, potentially improving energy density. It can even help with thermal management.
Charging, that's where wireless power transfer, WPT.
Inductive charging, parking over a pad is getting pretty good. The SAE J2954 standard covers stationary charging, up to 11 kilowatts now, with efficiencies around 90%.
The really exciting part is charging while driving.
That's the long-term goal. Moving charging from something you have to stop for to something that happens continuously, seamlessly while you're on the move. That would be absolutely essential for, say, highly utilized autonomous taxi fleets in the future.
And this whole wireless transformation, it's changing how cars are made. The whole smart factory concept.
Modern car manufacturing needs incredible speed and flexibility, and that is super reliable networks. That's why you see major players deploying their own private 5G networks inside their factories. These dedicated networks guarantee that ultra-low latency, sometimes even under 1 millisecond, and the rock-solid reliability needed for complex robotics and synchronized automation.
And think about the flexibility that unlocks. You can have autonomous guided vehicles, AGVs, moving parts around, robots working together, all without being tethered by physical cables. It means you could potentially reconfigure a production line almost on the fly, without massive downtime for rewiring.
So a secure, reliable, private wireless network isn't just a nice to have, it's a direct way to mitigate huge operational risk.
So the progress is undeniable, the potential is huge, but we need to be realistic about the hurdles too. There's still significant challenges, right?
On the technical side, achieving that true, ultra-reliable, low-latency communication for widespread autonomy, it's still a major headache, as we discussed. Getting latency consistently below 10 milliseconds everywhere, all the time, especially with all the sensor data flying around in busy areas. And then there's interoperability. A modern car is packed with different wireless standards. Making sure they all play nicely together without interfering with each other adds a lot of complexity. System integration is tricky.
And then you layer on the regulatory side.
You've got regulatory fragmentation, which means high compliance costs. Just look at spectrum allocation, the whole debate in different regions about using the older DSRC standard versus CV2X in the 5.9 gigahertz band. That forces companies to make different versions for different markets. Any wireless system that's safety critical, think WBMS, or parts of the V2X system, has to be the absolute highest level of functional safety certification. ISO 26262, ACLD. ASLD demands incredibly rigorous proof of safety, not just for the hardware, but for the entire software development process, testing, validation. Now think about an SDV getting constant OTA updates. You have to ensure every single software update maintains that ASLD compliance. It makes every OTA potentially a critical safety release, which is exponentially more complex and costly than certifying fixed hardware just once. And if we connect this to the bigger picture, as the Alpert research team concluded, cybersecurity is a paramount concern. Every wireless interface must be secured against hacking.
It seems the industry's approach is this multi-layered defense-in-depth strategy. You can't rely on just one thing. You need security built in from the chip level, like a hardware root of trust. You need strict processes following standards like ISO 21434 for cybersecurity engineering. And critically, you need secure signing for those OTA updates to make absolutely sure only legitimate, verified software gets installed. Plus, network segmentation, keeping the fun stuff like infotainment firewalled off from the critical driving systems.
Looking even further ahead, the industry is already planning for the next horizon, which is 6G. Maybe the most profound shift is something called ISAC, integrated sensing and communication. The idea is the wireless network itself won't just carry data. It will actively sense the physical environment with incredible accuracy. Think of it like radar, but built into the communication signal itself. Combine that with terahertz level speeds, and 6G promises the kind of instantaneous, ubiquitous connectivity and sensing needed for really advanced AI integration and truly seamless driverless systems. And all this wireless data, it feeds into another key concept, digital twins. These are essentially real-time virtual copies of the physical car running in the cloud. Manufacturers can use them to simulate performance under different conditions, run remote diagnostics, even predict when maintenance will be needed before something breaks.
That predictive maintenance piece sounds powerful.
The potential is significant. Estimates suggest it could cut lifetime vehicle maintenance costs by up to 25%.
Ultimately, all these advancements seems to be paving the road towards fully autonomous Level 4 and Level 5 vehicles.
In that L4, L5 world where the car is fully responsible for driving, you need that complete system reliability and autonomy. And that's where wireless power transfer, WPT, becomes truly essential again. Reliable, autonomous WPT is really the final piece needed for efficient, large-scale autonomous fleets.
So what does this all mean? The message is clear. Wireless is no longer an add-on. It is the infrastructure of modern automotive value. If you take away one thing from this review, let it be this. Wireless is now the central nervous system of the automotive industry, and mastering it is essential to driving the future of mobility. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.